Bienvenido a otro Renewable Tuesday con Glen International. Mi nombre es Pedro Vega y estamos aquí todos los martes. Y qué bueno que estén con nosotros cada martes. Vamos a estar educándonos sobre todos los temas solares y en el de hoy vamos a estar hablando sobre Ironridge y su ground mount con John Hain, que nos va a estar hablando sobre este tema bien interesante del sistema ground mount, más cuando está en temporada de huracanes que se está acercando. Y los dejo aquí con mi compañero John Hain.
All right, thank you for the introduction. I think we can start in here. So my name is John Hamey. I'm a senior technical support representative for Ironridge, and I've been in the solar industry for over 27 years, 17 years as a contractor and installer, and I'm certified NABCEP PV installer. Got that certification in 2003 when it first came out. And I'm still involved with NABCEP as a volunteer. And I've worked with 2 different PV module manufacturers and in technical support, and 3 years with Ironridge. And also joining me today is Carlos Maldonado. Sorry, Carlos, I forgot to put up your slide in this presentation deck, but he is also with the technical support with Ironridge and the QuickMount. He came over from QuickMount PV, and do you have anything to add there, Carlos?
No, pretty much covered it, but really nice to meet you all, and be happy to help with any support you guys may need. I am in the technical support side of things, so I'll be able to help with any questions you guys have regarding our racking system or mounting systems. And also I'm also on the training side of things too. So if you guys do need any additional support for training, we could definitely set up a virtual training, or we could set up a phone call to help, since I actually do hands-on training. So yeah, if you guys have any technical support questions, John or I will be able to help you and guide you guys and help you with installing the racking system.
Thanks, and I should also mention too that Carlos can speak Spanish, so
That's
that
right.
would be helpful too.
Yes. Y hablo español también. Si tienen alguna pregunta en español, con mucho gusto aquí les puedo ayudar también.
Very good. Okay, so today's agenda, I'm gonna do a brief introduction to Ironridge Company. And we're gonna talk about the Ironridge ground mount system and site conditions that you would encounter for your installations, and then go through the ground mount construction process and our design assistant. So a brief introduction here. Our history: Ironridge was founded by Craig Carney in 1996. He worked in the Ironridge offshore oil rig construction, and he saw a need for mounting systems for solar panels. At that time, I was an installer, and we were using aluminum angle and unistrut to mount things. There just weren't any pre-engineered systems. So Craig was a pioneer in the industry. Ironridge and QuickMount are part of the Esdec family. Esdec is one of the largest European rack manufacturers, and also part of the family are EcoFasten and PanelClaw, which are independent business units. Ironridge and QuickMount operate as one business unit. Ironridge makes a flush mount system for pitched roofs, a tilt mount system for flat roofs, and a ballasted system for flat roofs, and then what we're going to discuss today, the ground mount system. QuickMount products also are attachments for any type of roof, from comp shingle to low slope flat roofs to cedar shakes or slate or metal shingle roofs, tile roofs. We have a mount for just about every type of roof. So we have independent quality certification for our quality programs, ETL listing and ISO certification 9001. And then we also have internal test programs. We're part of a key test lab for Intertech, so that all of the part of the Esdec family can test in our test facility. So we'll talk about the ground mount system. And basically, I mean, it's a pretty simple system. We provide the engineering through our design assistant. We give you a layout and the bill of materials and pre-stamped engineering letters. And all of this complies to UL 2703 for bonding and grounding. You would get pipe locally for the substructure, and we provide the XR rails that you would get through Glenn International, your distributor. And there's really not a lot of special training or specialized equipment for the basic ground mount system. So we'll get into the details of the pipe later, but as I said, you would get steel pipe or mechanical tubing sourced locally. We provide the top caps and bonded rail connectors that connect our rails to the substructure assembly. There's an optional diagonal brace. This is only for concrete foundations. It's not an option with the ground screw foundations. And I'll explain that later. Basically, the sleeve that fits over the pipe doesn't fit over the ground screw. So, and it's not really required anyway. So, but it is an optional piece. And then on top for the array assembly, we have two options for the rails. We have our XR100 or XR1000 rail. And then we have the UFOs and stopper sleeves, which are the module clamps that hold the modules to the rail, and then the ground lug, and then accessories, the end caps and wire management and microinverter kits. So basically, it's a pretty simple structure where the substructure is made from either 2-inch or 3-inch grade B Schedule 40 pipe. And so this comprises the vertical piers and the horizontal members that run east-west. Then we provide the either XR100 or XR1000 rail that goes on top of the substructure, and the rails are oriented in a north-south vertical orientation. So the choices in our design are for either a 3 up per column, 3 modules up, a 4 up, or a 5 up configuration. The 3 and 4 up configuration has a north-south pier spacing of 7 foot 6 inches, and you can use either XR100 or XR1000 rail. Then the tilt angles is a fixed tilt, but you can select anything from 0 up to 45 degrees. The 5 up configuration has a 9 foot north-south pier spacing, and the only option for rail on that is the XR1000 because of the longer span. So when you choose pipe, whether to use 2-inch or 3-inch, 2-inch is more typical. It's easier to handle, but you do need more piers because it doesn't span as long a distance. 3-inch pipe can span longer distances and mean you would use fewer piers. We recommend to use our design tool and select back and forth between the two to compare how it changes the design and the cost. 2-inch pipe is a lot more costs a lot less than a 3-inch pipe and is easier to find. So, you know, basically all the components together here, the top caps hold the horizontal pipe to the vertical piers, and the rails are connected to the horizontal pipe with the rail connectors, and then the UFOs hold the modules on. So the UFO is our module clamp, and it comes as one piece, and it adjusts for module frame thicknesses from 30 millimeters to 46 millimeters. So you only need to carry around one piece for all the different types of modules that you would mount for your mid clamps. And then this also turns into an end clamp by snapping on a stopper sleeve. Another option is our Camo End Clamps, and it's not typically used on a ground mount, but the reason I bring it up here is that module widths are getting wider now. So if you have a module that is wider than 40 inches, it's not going to allow you a 5-up configuration on a 17-foot rail. So when you use camo, it allows you to cut the rail flush with the module. You don't need that extra inch hanging out for the UFO and stopper sleeve, pictured at the bottom there. And so it saves you 2 inches of rail. So in the case if you were using LG modules, this would allow you to, the camo would allow you to do 5-up on a 17-foot rail. Anything over that, you're going to pretty much have to be limited to a 3 or a 4-up configuration.
John, I want to add something to that too.
Yeah.
So one thing as well, if since John didn't bring up a really good point, the camo clamp is a good option whenever you have modules that are wider. And one thing also to keep in mind is that if it is wider, and even with the 17-foot rail, if the modules actually go past the rail, the main thing you have to be aware of, that the rail could actually be underneath the module frame just about a 1/4 inch. So it doesn't necessarily have to be flush with the module, although that's ideal. But in cases where the modules are a little wider, they could actually extend past a 1/4 inch and have the rail sit in under the module frame a 1/4 inch, no more than that. So just keep that in mind, that if there is a module width that is wider and you need to use a 17-inch foot rail, and the module hangs over the rail a 1/4 inch, it's still okay, but not more than a 1/4 inch on either side.
Yeah, good point. Thanks for clarifying that. And it also brought up another idea that I know that in hurricane-prone areas like Puerto Rico and the Caribbean, some people have chose, even though our system is engineered to those high wind speeds with either the UFO and stopper sleeve or the camo, some people have chose on their ends to use both combined, a camo and a UFO and stopper sleeve, as extra insurance. So that's an option that you might want to consider, particularly if you're right on the coast and your exposure is such that you really want that extra protection. So I also want to point out that we are a fully listed system, which means that the system is tested and evaluated to all the requirements of the standard, and that for UL 2703 in this case, and where classified systems are only tested to a portion of the standard and recognized as a component that's evaluated only to a portion of the standard. So we are fully listed to UL 2703 standards for bonding and grounding. And what that means is that you only need one ground lug for the whole ground mount array. So all of the bonding and grounding through the UFO to the module frame to the rails is done there, and the bonded rail connector bonds to the pipe, and the top caps bond to the piers. So everything, and then even if you're using ground screws, the hex cap screws also provide bonding and grounding to the earth screw. So only one ground lug per the whole array, and this meets all the grounding requirements. So our foundation options. So we've, for the longest time, this ground mount system is one of our older products that has been unchanged for the longest time. And only recently we added ground screws to our standard offering. So in our design tool and in our certification letters, you can choose either concrete or ground screw for your foundation option. If you need to do an alternate foundation, like say driven piers or a ballasted system or helical piers, you would need third-party engineering. But our design assistant provides reaction forces per pier to support the additional engineering. So, and we can recommend engineering firms that are familiar with our ground mount system. So the ground screw foundation is new for us. And so one thing I want to point out in this drawing is that the pipe insertion. So the piers, the vertical pier doesn't need to go all the way into the ground. It just needs to be 22 inches into the ground screw. And so you would use less pipe when you're doing a ground screw installation, but you would still need to buy the ground screws. So compared to our competitors that do ground screws, we have certification letters in 44 states, and the competitors have fewer. We do have 2 and 3 inch pipe supported choices, whereas our competitors are only using one pipe size, either 2 inch or 1.5 inches. And we work with 2 manufacturers for our ground screw configurations. Our competitors only have a single source. We have fewer components, so we don't require diagonal bracing with ground screws, so there's fewer components to buy where it is required with our competitors. So the 2 manufacturers that we do approve are Krinner ground screw or American ground screw. And Krinner is a German company that has that does have an outfit in California in the U.S., and they have maintained inventory throughout the U.S. And American ground screw is based in the Midwest, and they also have inventory throughout the country. So let's talk about site conditions. So, you know, when you're designing a mounting system, whether it's for a roof or a ground mount, you have to consider the dead loads, snow loads. I know Puerto Rico doesn't have snow, but you do have wind. So wind force both down and uplift, and then the bearing pressure of the soil and the skin friction of the soil. So our design tool is created to help you navigate all of the design considerations. So with the ground mount, you need to be concerned about the soil class. And so we use the International Building Code, the table from that shows the soil class. And the ground screws are certified all the way to ground for 1 through 5. And so it's covered in our standard certification letters. If you're using a concrete foundation, it's 1 through 4, and you would need additional engineering for soil class 5. So we always recommend when you're digging to call 811 before you dig. I believe that should be true in Puerto Rico as well. It is through the rest of the continental U.S. Always understand what's buried there so you don't hit electric lines or gas lines, you know, phone and cable lines, water or sewer lines. Have those things marked before you dig holes. And if you're building a system for a customer, you want to go to the site and do test drilling to see what you have. What kind of soil is there? Are there rocks? Is there groundwater? What is the soil type? Just, you know, have some test holes to get an idea of what you're going to be dealing with. You know, it could be perfect soil conditions. You might have bedrock, solid granite, or you might have large rocks or groundwater. And all those things need to be considered when you're selecting a foundation. So if you hit groundwater in stable soil, you know, you can continue augering and to the depth required. If you have poor soil, we recommend you use a sonotube as a sleeve as you auger to keep it from caving in on you. And always check with your local building authority to see if you can pour concrete into a hole with groundwater present. You may be required to use a high volume pump to remove the water immediately before pouring concrete if you're doing a concrete foundation. So I know that this is probably something that's not of concern to anybody in Puerto Rico or the Caribbean, but frost and frozen ground is something to consider in northern climates, and you need to know the frost depth and build your foundations below the frost depth. And in our design tool, there is a selection where you would put the frost depth and then select your ground screw length based on the frost depth. So In Puerto Rico, you would only need to use the shorter screw length because you don't have freeze thaw there. So if you're building on a slope, ideally you want to build on flat ground, but if you're building on a south-facing slope, we can accommodate that easily. And so in our design tool, we have a place where you can put in the desired tilt, that the tilt angle towards the sun, and then you can also put in any what the tilt angle is of the hill or slope, and it will automatically calculate the foundation depths and the length of the north piers to adjust for the slope. If you're building on an east-west slope, there are some limitations. So our standard design is for 30 inches above grade is the maximum height. So you can be lower than that, but you just can't be higher than that. So if there's enough slope where it's going to exceed that, what we recommend is to break up the array into smaller pieces and step down the hill to deal with those situations. So the ground mount construction. So if you're doing concrete foundations, you're going to use 2,500 PSI concrete mix, whether it's bag mix and you're mixing it yourself or having it delivered pre-mixed. That's pretty common grade of concrete. And our design tool will tell you how much concrete you need based on the hole size if you're doing that. And then you would also buy your pipe locally. I have a slide, we'll go through the actual pipe dimensions and specifications. And then the ground screws you would also buy separately from the system that we provide, whether it's directly from the ground screw providers or if your distributor carries ground screws. And the the American ground screw and Crinner model numbers are listed here and also in our installation manual, depending on whether it's a 2-inch or 3-inch pipe. So this is our pipe specifications. It's in our installation manual, and it's really important because we're using a structural grade of pipe we're recommending to use. And so if you were using Schedule 40 grade B pipe, that means it has to be ASTM A53 grade B, and 2-inch pipe is actually 2 3/8 inch outside diameter, and 3-inch pipe is actually 3.5 inch outside diameter, because pipe is normally sold for the nominal inside diameter. So to work with our top caps and our bonded rail connectors, make sure you understand it's either 3.5 outside diameter or 2 3/8. And don't buy grade A pipe because that is for plumbing or conduit, and it's the grade B pipe that's the structural strength that we're looking for. The other option is mechanical tube. So if you're using 2-inch, it's 12 gauge and 50 KSI yield strength, either from Allied or Wheatland. And I have another slide with that. Or if you're using the 3-inch, it would be 8 gauge and 45 KSI. The nice thing about mechanical tube is that it's lighter. It's 30% lighter than Schedule 40 pipe because it has a thinner wall, but it's a stronger steel. And it also comes in 24-foot lengths versus the 21-foot lengths of Schedule 40. So I like to use mechanical tubing when possible. And we have links on our website to suppliers of mechanical tube. And we recommend to use that where you can. So when you start the construction, you want to make sure that you understand your location and layout are clearly marked. Know that there's any boundary lines with the neighbors' property lines or anything like that, or if there are septic drain fields there. Make sure you understand setback requirements for property lines, and verify your layout before you start. Always, we recommend to wear safety gear, work gloves, eye protection, ear protection, steel toe boots. Follow OSHA safety guidelines when you're working with the crew to stay safe. So you stake your foundations based on your plan and measure twice before you dig, because it's a lot easier to make changes while you just have a stake in the ground rather than changing a hole once it's dug. So check make sure everything is measured correctly and the spacing is according to your plan, and then use the diamond, that diagonal bracing, or measuring diagonally from corner to corner to determine that it's square. When those are equal, those measurements, then you have a square layout. So this is from a recent installation using ground screws, and one of our guys went to this site, Mitch, and he reported back that when you're doing a large system, make sure that you're using a steel tape rather than a vinyl tape, because vinyl tapes tend to stretch, and a steel tape will give you accurate measurements, especially when you're measuring out a long run like that. And I wanted to point out that in this top picture, you can see all of the ground screws that are laid out there. This was a fairly large system. That machine on the bottom picture put all of those ground screws in one day. Actually, it went over a day because they had to remove some and replace them for clearance for a fire road. But the point is that you can put in a lot of foundations using a ground screw installation versus if you had to dig all of those holes and pour concrete in all of them, which would take a crew a lot longer time to do. So ground screws do take specialized equipment to do. So there is a handheld driver that works okay in lighter soils. If you have hard soils, this might not be the best option. So making sure you understand the soil conditions is really important here. It's just an electric driven rotator, and then there's that diagonal brace to keep it from spinning so you don't dislocate your shoulder. The machine mounted, on a skid steer or a mini excavator is the more common method. It's a low speed, 15 rounds per minute, high torque rotator. And here's some other examples of that from Crinner. And they actually have a specialized machine on the right there that's all it's designed for, is for putting in ground screws. So when you're putting in a ground screw, the way to keep those straight is to use a level with a magnet on it and stick it on, 2 of them on there, and keep, start out straight and then keep checking it as you're going down to make sure it's straight. You can make small adjustments, even up to 2/3 of the way down. And then, it's really important to have it placed straight so that later everything goes in straight. So ground screws install in a clockwise rotation, and they can be removed by rotating them in a counterclockwise direction. So make sure that you provide enough downward pressure to advance 1 thread per rotation. Not enough pressure results in churning the dirt, and dirt is ejected, and too much pressure results in augering, where the screw acts like a drill. So, and if the hole gets too loose, you can add some 3/8 gravel to it and screw back in, and it'll tighten right up. So if you have hard rock or hard soil or bedrock, you can pre-drill holes. So if it's just hard soil with some rockiness, you can use that hand-operated drill and drill to 1/3 the size of the ground screw to pre-drill it. And if you're in solid bedrock, you're probably going to need a more serious drilling machine that can drill out to a slightly larger hole than the ground ground screw, and then you would backfill with the 3/8 gravel to provide friction for the ground screw. So we provide the hex set screws for ground screws. When you design in our design tool using ground screws, this will automatically be put in the bill of materials. If you're using American ground screws or 2-inch with either, it will use 3 hex head bolts, bolts per ground screw. If you're using 3-inch Crinner, it'll take a set of 4. So you need to select that in the design tool based on which ground screw you're using. And American ground screw uses the Model 3, either the 76 millimeter for 2-inch pipe or the 102 millimeter for the 3-inch system. And then Crinner uses their model KSF G76 or the KSF G114. So if you're using ground screws, it's a good idea to have an M16-2 tap available so that if any of the threads gets damaged, you can tap those out. Because sometimes when you're turning these in, it's a lot of high torque and it can distort the threads a little bit. So putting the hex head bolts in ahead of time and then before you turn these in is a good idea, and then having that tap in the event that you need it. Also, it's a good idea to mark your 22-inch pipe insertion length on the pipe before you put it in, so that way you have a mark to know how deep to put it in, at least that depth. And then the beautiful thing about ground screws is that you can set a string line at the height that you want and then pull those up to that string line and then tighten them. So you get everything nice and straight and it's adjustable. Whereas if you're doing it with concrete piers, once the concrete sets, there's no real adjustment to that. And then you can also verify your tilt angle as well. If things are slightly out of plumb, didn't quite go in straight, you can straighten them after it's installed, using a come along or a strap like this with a ratchet strap to pull that back straight. And then when you put the rails on, it'll actually hold it straight. So there is some adjustment that you can make in the field. And then when you're putting your rails on, make sure that those are square. Your end-to-end dimensions are even, and then measure diagonally to get it square. And then you will be ready to put on the modules. But we're going to go through the ground, the foundations using concrete next here. So this would be more common for smaller systems and where you only have a few holes to dig and you don't have access to the equipment that you would need to use for ground screws. And, it's best if if it's only a few holes and they're not really big in diameter, you can hand dig them, but it's more common to use a tractor mounted auger for drilling or a 2-man motorized auger. I don't really care for those because if they hit a rock, it can damage throw your shoulder out of alignment when those things kick and hit a rock. So I like the skid steer mounted augers or tractor mounted auger. So we recommend to support this, assemble and support the whole substructure before you pour the concrete. So that means setting up scaffolding to support the horizontal pipe, and then putting your piers and hanging them into the holes. That way you can measure everything, make sure it's all straight, level, and where you want it before you pour the concrete. And you can reuse these pieces of lumber later if, for other uses, or if you wanted to use them for another ground mount system at another time. Or you can use pipe stands if you have access to them. And if you do a lot of ground mount systems, these might be worth buying. And it's a quick and easy way to adjust holding up the horizontal pipe and fine tuning everything before you pour the concrete. If you're doing concrete foundations, you can use the diagonal brace. It's really important to put this sleeve on before you put the horizontal pipe on, because it slides over the top. And if you put the whole system together and then realize that you forgot to put the diagonal brace on, guess what? You have to go back and take everything apart to slide those on. So that's not fun. So it's really important, if you're using diagonal screws, put those on before you put the horizontal pipe on. So it's important to follow all the torque settings for all the hardware. And there are labels on the top caps, depending on the type of pipe you're using, which torque setting to use. And those are on there. And the U-bolt doesn't need to be over tightened. It's only 180 inch-pounds, and the set screws are a little heavier torque at 240 inch-pounds. If you're splicing your horizontal pipe, you can do that over a top cap without any coupling or additional pipe, as long as it's one of the interior piers, not the last pier at the end. And the U-bolts on the top cap will hold that in place. If you're using Schedule 40 pipe, you can use a threaded coupler. And if you're using mechanical tube, you would buy tubing that's just one size smaller. So if you're using 3-inch pipe that has a 3.5-inch OD, you would use an interior piece of tube that is 3-inch OD, and use set screws, self-tapping set screws to hold that in place. And those specifications for the pipe size and splice size are in our installation manual. There are splice rules for the horizontal pipe. You cannot do it in the cantilever, which is the last, where the pipe sticks out past the last pier. And you don't want to do it in the middle of any span. And you don't want to do it at the last, near the last pier either. So any of the interior spans near the pier in that 1/3 of the span is acceptable. Or on the pier itself, if that's the method you choose. So there are different ways to assemble these. You can pre-assemble on the ground on horses and then use equipment to lift it in place, or you can use a ladder and set the modules individually. Do not climb on the array, use a ladder. This is very dangerous, what this guy is doing in the picture. And it can damage, he can fall and hurt himself, or the modules can be damaged. They might not appear to be damaged, but they can get micro cracks in the cells by stepping on them and putting too much pressure in any one location. So we recommend using a torque wrench set to inch-pounds, not foot-pounds, and also to use a drill with a clutch set at low speeds for attaching the hardware. And then you can go back and test with the torque wrench to fine-tune that clutch setting on the drill. Never use an impact driver for the hardware because it can strip the hardware and over tighten it for a ground mount system. So the rail assembly, once you have the substructure in, is the same whether it's ground screws or concrete. And the rail spacing is determined by the module manufacturer's clamping specs. So always check with the module manufacturer installation manual to determine where they allow for clamping on the module. And you can turn the module over and see that there are usually holes if you were to bolt that directly to something. And usually there are 2 holes at the top of the long side and 2 at the bottom of the long side. And usually in between those 2 holes is the clamping range that most module manufacturers use. So that would determine where the rails are spaced. And then you run a string line and bring all the rails so that they're equal distance top and bottom, so that you're distributing the load evenly on the array substructure. And then make sure you're squaring the rails diagonally before you start putting modules on. And here it's important that, you know, when you put the rail connector on, it slides into the rail with the hardware provided, and then there are U-bolts that connect it to the pipe. And the torque spec, don't confuse these, so it's really important that you torque to 21 foot-pounds for the bolts to the rail, but for the U-bolts, you only want to use like 5 foot-pounds on either, you know, each side of it equally. You don't want to over-tighten those. So now before you put the modules on, this is where you, if you're using microinverters or optimizers, this is where you would put those in. Think about, you know, how to orient your panel junction boxes so that you're shortening your wire runs as much as possible. And you would use our microinverter kit to, there are these small T-bolts to attach the microinverter or optimizer to the rail. And then use our management clips to do wire management at this point is easy as well. So with ground mounts, I like to start in the middle and work out so that you're, you know, any errors in layout don't get multiplied too much by starting at one end. And, you know, that way, make sure everything is going in straight, and then leave a 3/8 inch space between your columns, as well as 3/8 space that the UFO has between modules going up the column. So that way everything looks nice, but it also allows for expansion and contraction. So this would be, you know, the finished array where you'd go in and do wiring. The other thing to point out is that the UFO T-bolt, make sure that it's fully engaged in the rail by lifting up on the modules after you installed them, because there's no indicator mark on there, so you can't tell by looking at it from the top whether it's fully engaged in the rail. It may have tightened up against the bottom of the module without engaging in the rail. So always pull up on all 4 corners of every module to make sure it's fully locked in place before you move on. And then this is what a ground screw or ground mount looks like with ground screws from the back. So less interruption to the ground there, but it's a nice clean installation. So now I want to show you our ground mount design tool. So let me make a switch to there. And let's see here. I want that. Here. So if you go to our website, and I've got so many windows open here. So anyway, on our website, always across the top, we'll have, you know, Ironridge, and then different systems: pitch roofs, flat roofs, ground-based, and design tools. You want to, if you need documents for a ground mount, you would hit this ground-based here, and in the drop-down menu, select ground mount documents. And then on this page, you will find the installation manuals, tech tips. This is where the suspending pipe and concrete, there's a nice tech tip for that. And then also the data sheets, certification letters, and the cut sheets for individual parts here. And then this is also links to U.S. wholesale pipe and tube, where you can buy a mechanical tube or Tubular USA. and then also American ground screws and Crinner are here. Eco Foundation Systems is an installer of ground screws, but they're located in California, so that's mainly for our California folks. So then when you want to use our design tool, this is where you would select in the drop-down menu for ground-based systems. And if you've already set up an account with us, well, if you haven't set up an account, please do. It doesn't cost anything. It's free. You just, you can create a login and a password, and then you will have a list of all your projects. And this is where it says My Projects up here. You would click on that, and then it'll take you to your list of projects in the design tool. And you can combine projects here. So if you were gonna, say you wanted to submit bill of materials to Glen International here, you could click on Consolidate Bill of Materials here, and that would be an option. Also, there's other options here as well, where you can clone a project and create, you know, another project using the same configuration. So we'll go into this project here that I started, and basically in the beginning you would put in your address or your zip code, and then it's going to take you to this page, and then you can put whatever you want for project name here, and then choose your code. So in Puerto Rico, the ASC code is 716. In some other states, it's 710. The International Building Code 2018 references ASC 716. And based on your location, the wind speed and the snow load will automatically populate. Obviously, you don't have snow in Puerto Rico, but you do have high wind speed. And then you would select your wind exposure here. If you have a question of what something means, click on this little eye here, and it'll give you a pop-up window explaining that, you know, exposure B means you're in around buildings and trees. Exposure C is more open terrain with scattered obstructions, and exposure D would be on, like if you were on the coast. And then you would select the solar panel. The module manufacturer would be here. And then you would go through and select the module manufacturer and the model number, and that way you can and then save the project. So if you're using UFO and stopper sleeve, this is where you would select that, or if you want camo. And then if the module frames are black or clear, you can select the hardware will be for the UFO and stopper sleeve. You can select black or clear here. So then in the next section is a substructure and foundation. So it defaults to ground screws, but you can select concrete here as well. Well, I'll show you both examples of both. And this is where the tilt angle that you want for your array. And then this, if you have a south facing slope, you would add that here. And then you choose your pipe size here, 3 or 2 inch, and the ground screw length here, what is commonly available. And then we won't worry about freeze thaw depth for Puerto Rico. And then hex head screw set, 4 if you're using 3-inch Crinner ground screws, or 3 if you're using the American ground screws, or 2-inch Crinner. Soil class is defaulted already for ground screws, so then you just save. And then this is where you need to add your configuration here. So you click add, and then you can select here whether it's 3, 4, or 5 modules high. And here, and that would be the modules going up, north, south on a column. And then this would be the number of columns across. So we did 4 by 10, then you're going to have 40 modules. So look up here to confirm how many modules. This gives you a summary every time you make changes down here. So here you can see that with the 150-mile-an-hour wind speed, we have a 7'9" pier spacing using 3-inch pipe. And this is our ground screw selection here. So if I go back up and say if we were going to have a south-facing slope of 15 degrees, and you click save, you can go back down here and it will show you, it will change this pipe length here to adapt for that slope in the hill. So we'll take that back to 0. I just wanted to show you that. And then also, if you wanted to change your pipe size to 2, you can compare that. So I always recommend, play with this tool and make changes so you can see what the difference makes. So now you can see that the pier spacing is closer, 3'5". So you're going to have a lot more piers, but it's a lighter weight pipe. So, those are selections that you can make based on the system, and you can see how it affects, your costs, both for the pipe that you have to buy and also for the number of piers that you have to put in. So if you wanted to use concrete foundations, now you still have the south-facing grade and the tilt angle here, but now we have options for soil class here, up to soil class 4. And that's the worst case, so we default to that unless you know. And also we have hole diameter. It defaults 12-inch holes here. But you can choose larger holes, and I'll explain that in a minute here. So once you save that information, you can see that now we have a 4'6" deep hole here, and for concrete using a 1-inch or 12-inch, 1 foot hole diameter. So that's not bad, really. If you were to change this to 3-inch pipe and add that, we'll see what that does to the changes here. So now you have 10'6" east-west pier spacing, but your hole depth went to 7'6". So that's pretty deep hole. But you can come up here and make that wider and change that, and you can see that now it's only 5'6". And this is because you have such a high wind and a lot more weight here. You could also add diagonal bracing and see how that affects it. So now you have diagonal bracing and the hole depth is only 5 foot. So it did reduce that, and the pier spacing went to 10'9". So those are all changes that you can make in the design tool to get exactly what you're looking for in terms of your system. So
John, I would also like to make a comment.
Yeah.
One thing they could also do is where it says max span, they could always hit custom and reduce that max span to also reduce the hole depth.
Yeah, that's true. That's very true. So then you increase the number of piers. As long as you don't go over the max span, you can have less and more piers, and that would reduce that hole depth. Good point.
Cool.
And we can, so that's that. So then once you have everything the way you want it, then you go to the bill of materials page up here. And this is where you can add accessories if you need wire clips, end caps, and microinverter hardware. And you click save, and that is added down here to the bill of materials. So then you take this bill of materials and you can email that to your distributor, Glen International. And up here is where the report is, the project report that you would submit for your building permit. And then this is also the bill of materials, either in a PDF or a spreadsheet version. And send that to get a quote on your materials. And also, all your documents will be here, the ground mount system and everything. So we don't currently have certifications for Puerto Rico for ground-based systems, but we do have an engineering firm that we can work with to get that. So we'll have to, as we get into that, if you have a system, please contact us at support@ironridge.com and we can help you out there. So I think I've covered everything. I know we've gone through about almost an hour now. So are there any questions? And you can type those into the chat. I don't know. Can you see the chat, Carlos?
Yes, I see that there is one question, and it's in Spanish, so I'll go ahead and read it. It says, el tubo que se usaría sería rígido o semirrígido. Y la respuesta de esa pregunta es que tiene que ser rígido. Y especialmente si van a usar el de 2 pulgadas, tiene que ser rígido, o el de 3 pulgadas también. Si pueden encontrar el Schedule 40 pipe, es el que recomendamos, o también el mechanical tubing, que es un poquito más delgado, pero el metal es más reforzado para que esté más más fuerte, pero va a ser un poquito más liviano para poder instalarlo más fácil. Pero espero que haya contestado bien la pregunta, pero si tienen alguna otra pregunta, háganos saber y les podemos ayudar con mucho gusto.
Perfect. Glad you handled that one.
Hola, ¿qué tal? Soy yo otra vez, Pedro Vega.
So any other questions? And if you don't have any questions or you think of some later, please.
El sistema ground mount, lo importante que es las condiciones del site y que hayan sobre todo aprendido cómo utilizar este Design Assist de Ironridge, que es súper bueno, y que vamos a estar viendo entonces a John y a Carlos, lo vamos a estar viendo la semana que viene con el sistema Ballasted. Espero que puedan seguir viniendo a todos nuestros Renewable Tuesday para seguir aprendiendo con nosotros. Y
nada, también queremos recordarles nuestro evento Energy 2021.
Va a estar bueno.
Noviembre 18, no se lo pueden perder. Gracias por su participación y nos veremos el próximo martes.
inscríbanse, por favor.
Gracias.